Okay, so on the bench today, we do not have a radio. We have some actual radio test equipment. One of my probably favorite pieces of test equipment. This is a BK Precision 1040 CB Service Master. Now this one is not mine. This belongs to a customer. He's been having some problems with it and asked if I could take a look at it. Like I say, one of my favorite pieces of test equipment. I use one pretty much 7 days a week. I have one right there you occasionally see in a video, and that paired with the matching 2040 signal generator makes this combination probably one of the best CB service setups that there is. You can do a phenomenal amount of diagnostics and repair with those two, and then pair that with a frequency counter and an oscilloscope. And one of the big advantages of these is, on the back side, there are actually 3 connections you would make. So the output from your, like if you had the 2040 matching signal generator over there. Actually, you can use any RF signal generator, but specifically if you use that one, that's what it was designed to be used with, because that one is channelized for working with CBs. So you just hook up a coax cable from the output of your 2040 to the RF generator input on this. You would have a BNC cable that runs from the frequency counter output here to an external frequency counter, and then again here from your oscilloscope output on this over to an oscilloscope, which on my bench I have a frequency counter. This Ballantine counter down here is permanently attached to my 1040 over there, and then this bottom BK Precision oscilloscope here is permanently hooked up to my 1040 over here. I have that hooked up in through channel 2. That's a 4-channel oscilloscope. So, I still have other channels I use on it, but like I say, I have permanently channel 2 is attached to my 1040. And with that set up, like I say, you can do an amazing amount of diagnostics with it. I don't want to say they're some of the most misunderstood pieces of test equipment, but I don't think most people use these to their I don't want to say full advantage. I guess I could say they don't use all of the features that they have. I think a lot of people, radio collectors. Now, honestly, if you're a collector, do you need one of these? No. It's kind of a waste of money. The person I'm fixing this for sells a lot of radios. Now, he does some minor repairs himself, and then anything else gets sent to me to fix. But like I say, he sells a lot of radios, so he actually has a need for one of these in a signal generator. For the average radio owner, do you need one of these? Absolutely not. It's overkill. It's just going to take up bench space or table space. You really don't need one. But if you're a tech, great pieces of equipment. I've got, I think, 5 of them. I think I've got 5 of these and 4 or 5 of the 2040 signal generators. Yeah, I've got a stockpile. That's how much I like them. But you can do distortion measurements with this. You can check your audio output, how many watts audio output you're putting out. It has built-in, speaker dummy loads for 4, 8, 16 ohms. You change the scale for the watt meter. Has percentage distortion. I think that's one feature a lot of people don't use. Has built-in single and 2-tone generators for doing AM and sideband modulation. You can hook up an external audio output. So you can also have your receiver input into this. You can hook up, this has a built-in internal dummy load. Kind of in the glare there, isn't it? There we go. Has a built-in external dummy load, or you can switch to external. If you switch to external, so you'd hook up your transceiver here where it's marked transceiver. And then if you have, which on mine, it's just hooked up to an antenna. So my external, or well, actually not just straight to an antenna, mine goes through a coax switch. But, you can hook up an antenna here. So you can go on air Or, so if you're in the external position and you had an antenna hooked up here, you could be on air and then go to a dummy load. So, that way you're not testing live on air. You just go to the internal dummy load. This is also an average and peak reading meter. Also has blasted glares right where we need to be seeing. Has 3 scales for the meter. For your transmit power meter, has 10, 50, and 100 watts. Now the 100 watts, don't go putting 100 watt carriers into this. I have let the smoke out of mine numerous times over the years. No smoke to the point of it damaged it, but it's one of those, you're keying a radio and you happen to look over there and go, what the hell is that coming out around it? Because there's not really any vents in this thing. You just see some smoke starting to waft out around the cracks around the ends of the caps. And I've had all of mine apart and seen, it's just a block of a bunch of high power resistors in there. 100 watts peak, yes, not a problem. So 100 watts sideband power, this really doesn't have a problem, but you definitely don't want to be doing 100 watts continuous, like an AM carrier into this thing. But like I say, it has also a built-in SWR meter. So it's forward, your reverse, and then a set position for actually setting. You key your microphone, adjust it to set, just like any regular SWR meter, and then a read position. But actually has the reverse, so you can actually read how many watts reflected you're getting back. Now that's if you're using the external load. But so like I say, it's a very handy piece of test equipment, and paired with a couple other pieces of test equipment makes it a almost complete test bench. So we'll get this critter taken apart, and I can tell you from experience, because like I say, all of the ones that I have been rebuilt. That's one of the reasons he sent it to me. He knows I've worked on them before. I don't want to say they're a pain in the ass to work on, but they're pretty much a pain in the ass to work on. You'd look at it and go, well, it can't be that complicated. Actually, no. I mean, it does have a lot of circuitry in there, but it's not that complicated. The problem is getting to it. The design. You've got 2 end caps and a bottom plate that comes off. You got 2 screws here and a screw there. The bottom plate falls off, or actually in 2 there, and then couple more screws, and the end caps fall off. The problem is once you pop this apart, and you will see, you're looking at the solder side of the board, and you cannot get to. You can only get to a few of the outside components. So let me get this cracked apart here, and we'll continue on with checking this thing out, and we're going to completely dismantle it, because as far as I know, this is all original, so it has, all original electrolytic capacitors in it. So, we'll be changing all of those out, and then we'll see if how it looks on the inside, if the resistor bank's burned up. I know it is pretty far out of calibration, that's for sure. The watt meter is, it's definitely reading way low. I haven't even checked the distortion measurement. The tone generator does seem to be working fine, 1 and 2 tones. The switches need to be clean, because sometimes I can hear a little bit of a tone when it's supposed to be in the off position. It's a little bit stiff. So, that'll get some cleaning and lubrication. All of the switches will. But so let's get this thing cracked open and see what we have inside. Okay, so herein lies the dilemma of working on a BK 1040 CB Service Master. The layout. Yes, you're looking at pretty much, that's all the access you have once you remove the bottom cover and the 2 side end caps. And yes, we definitely have had some repair work done on this before. So that is, it's not the switch. That's the relay. So somebody obviously did not know how to properly do any soldering, which is sad, because if you're using one of these, you probably should be a tech. And they did such a crappy job unsoldering the switching relay inside of this. They ripped one of the traces off. So we'll have to straighten that out properly. That's a shame. But like I say, that's the problem, is getting into one of these things. You have to, basically, what's holding this in is all of the controls. So when you pull the knobs off, there's nuts underneath all of these controls. And I have to pull the camera back a little bit here. But you can see they had these big standoffs here, but that's actually what's holding this circuit board in, is actually all of the controls. And then on the back panel here, there are a couple little brackets that come off. But yeah, so, and of course, then even once you get all of this off, you still can't remove it, either of these circuit boards, because all of the wires and your coax cables are only about that long. So you can't get the board up far enough to really do anything. And the same thing on the back side. You really can't get the boards up and out far enough to do anything. So yeah, it's a matter of taking all the knobs off, taking all the nuts off, removing a couple screws that go to this rear mounting bracket that runs the whole way across, and then you have to disconnect basically all the wires off the front here. It's been a while since I did one. I think there's one or two wires you pull off on the back, and then you'll still have this still partially assembled, but that allows you at least to get it up to where you can get both of these boards folded up so you can actually work on it then. So let me get the crack in at getting this thing dismantled a lot more, because that's exactly what you have to do, a lot of dismantling. Now, one thing I will say, it doesn't look like this thing has had the smoke let out, because you see right here these two long traces. Actually, this is the ground plane, but these long traces right here. On the other side of this, that is the dummy load for this thing, the built-in dummy load. There's a bunch of big power resistors go right across here. What you do want to see when you take the bottom cover off of these is not black, and it's not. So that's a good sign. It hasn't been hot enough to where it's, baked the circuit board. So, like I say, those things, you can get them hot enough to where you'll get a little bit of whiff of smoke might leak out around the corner, and you really haven't harmed anything as long as it hasn't been hot enough to, really cook the board. Like I say, I've just learned over the years, don't put 100 watts into this thing. Like I say, 100 watts peak or 100 watts sideband would be fine, because that's not a continuous carrier. You're only going to be reaching those peaks. You gotta remember, when you're in peak reading mode, it's only when your waveform gets up to that level. So it's only there for an extremely small amount of time. But like I say, that's a good sign. I can see the solder joints are still nice and shiny on those power resistors, so they haven't gotten hot enough to melt the solder. Kind of wonder why in the hell they had to change the relay. I mean, I've never had to change one in any of mine. Mine get used a lot. Maybe the contacts were dirty. That's very possible. And they didn't think about cleaning them. They actually replaced it. So we'll take a look at it. Like I said, I'm going to have to clean this up a little bit here. They didn't clean any of the residue off, and they ripped the trace off. So I'll get that repaired properly. It looks like, I don't know if that potentiometer may have been replaced. They just reflowed the solder maybe. Now that's actually not uncommon if you have one of these. These solder joints on a lot of these controls might break loose after several decades of these things being in use. So just go over the circuit board, check all of the solder traces on this, because unfortunately probably some of the most abused equipment on the planet is test equipment. I see people that work on radios that take immaculate care of customers' radios and beat the living snot out of their test equipment. Because I've seen some of these things in horrible condition. I mean, God, you've got to wonder what did they do to their poor 1040s. I understand they're laying down. It's kind of hard, but mine's over there. Mine's not all scratched up. I vacuum the dust bunnies off of it once a week with a vacuum dust brush. One of these. Keep it cleaned. Wipe it down with some glass cleaner a couple times a year. And it still looks fairly close to brand new, But, so, let me get into the disassembly a little bit more, and the next time you see this, it'll be completely blown apart. Okay, so you can see we now have it dismantled. Like I say, taking out, there's 4 screws around on the edges of each of the boards. So, one there, one there, one there, one there, and then same thing along the back edge. There's little mounting tab brackets that come out. Remove the nuts from the 4 large controls, and then you can pull. Actually, this board's easy to get out. You can see this one completely removes from the unit. Once you have the 4 mounting screws and the 2 nuts off of these controls, you'll be able to pull this one out, and it just unplugs right here. So there's the connecting plug. So that one's very easy just to get out. This one's a little bit more challenging. Not that bad. Like I say, it's remove your 2 coax connectors. Just take the nuts off from the outside. Luckily they use the ones, the style jacks that have the nuts on the outside, not the inside. So you can just remove the nuts, pull those jacks out, and you'll need to unsolder 6 wires off of the board, 2 for the speaker and 2 for the audio out and the 2 for the receiver audio. So you don't really need to make a diagram when you're pulling that apart, because B&K did a very good job at laying this board out and silk screening it. So the audio, as you can see, is marked right on the board. The ground plane's rather obvious. It's the big metal surface here, so you know which ones are going to go to which. But anyhow, there so there's audio and the speaker is marked, and then the only other 2 you have are the receiver or the audio output, and they hook up right here where there's C on the board. So that hooks up right there, and this will be the hot wire or the yellow wire that's right here. It goes to the audio out, and then the black wire, of course, then just goes down to board ground right here. And as you can see, this is a double-sided board, so use precaution when you're desoldering stuff and taking it off. Don't want to go ripping traces off or damaging anything. So inside, like I say, there's a good bit of components on here, and this is your dummy load. So they look nice and shiny. No signs of ever being hot, so I'd have to say, yeah, this thing's never really seen any high wattage. They look as good as the day they were installed. Really good looking. Switches need to be cleaned. Contacts, I will pop the cover off of the relay and clean the relay actual contact fingers in there. Only other thing really it looks like it's going to need, replace the electrolytic capacitors. There's a big axial one here and a bunch of smaller ones around the board. Definitely want to go change. You definitely want to change all of these little tantalum capacitors. Always a good idea to change those little time bombs. Where an aluminum electrolytic slowly goes bad over time, and a lot of times you'll notice a problem long before it becomes a dead short and explodes. Tantalums have one failure mode, and that is a dead short, and it can sometimes damage other components. So, and most of these tantalums on this board, they're attached directly to a semiconductor, either a transistor like right here or to this IC right here. So yeah, you don't want them going dead short, so it's always a good idea to replace those as well. The audio board right here, you see there's not really much to this. So this has the distortion meter and your audio power. So for audio power, remember this has a selectable dummy load for either 4, 8, or 16 ohm outputs. And the way they do that is with these 2 large SandBlock 8 ohm resistors. So depending on what switch position you put this switch in, it either selects either just one SandBlock resistor for 8 ohms. If you have it in the 4 ohm position, it has both of these resistors in parallel. And then if you put it to the 16 ohm position, it's both of those resistors in series. So, like I say, very simple circuit. There's all the calibration pots for everything. You can see all the other calibration pots down here on this. But fairly simple, straightforward to work on. They were nice when they designed these that they did put access holes on the backside here. So, when these are calibrated, you can easily you don't have to dismantle them other than removing the bottom cover. All of the access points are right here. So, like I say, actually this one looks in really nice condition, not only externally but internally. Like I say, not sure why someone removed the relay. I probably am going to just remove that. Just desolder it, because I got to clean up that mess there anyhow. So, I'll just pop it out, and that'll just make it easier for me to clean the relay contacts then. So, let me get to work here, and we'll get this thing rebuilt. Okay, so I'm getting capacitors changed. Actually, I've got all these replaced now. Just reflowing some of the solder joints. I usually just redo all of the controls and the switches. They take a lot of abuse. And I got that done. I'm just inspecting everything, and I see something that's wrong, and it might explain why he's having power problems or meter reading problems. Let's see if you can spot this. So it's on this board right here. I'll give you a hint. It's on the left-hand side. The problem's at the meter. Have you noticed it yet? There's no solder. The terminals are, the wires are through them, but there's no solder on the terminals. The meter over here, yep, we're good. The meter over here, yeah, not so good. So, it's one of those things, you know, it's probably been making good connections for years, but since it's not soldered and it's not a, you know, a true wire tie style, you know, it's not wrapped around extremely tight, it's finally starting to give out. So yeah, that's definitely going to cause some meter problems. So we'll clean that up with a fiberglass burnishing brush and get those wires soldered to the terminal so the meter might actually read a little bit better. Okay, going to have to do a tiny bit of hand camera work here since what I normally stick my camera on is in use right now, which is this is a microscope mount. It's kind of my multi-purpose does everything mount. What I'm doing is curing the epoxy from doing some circuit trace repair. So we had the trace down here that someone had just bodged in a piece of wire. They'd ripped the trace off from that relay. So I've removed that piece of wire, cleaned the circuit board, cut out a copper trace, and what I'm doing now is, so I don't have to wait 24 hours, is I'm heat curing the epoxy. So it only takes about 10 minutes. So let me take a temp reading here. Looks like around 175 is my hot spot, which is fine. I just don't want to let it get up above, say 210, 220. So I usually do it around 170, 180 degrees when I'm doing the heat curing. That's not at the, that's actually a little bit below their recommended heat curing temperature, but I just do it at a little bit lower temperature for a little bit longer time. But now one thing you'll notice is there's no hole. In the middle of that pad right there. Actually, what's holding that down right now so the epoxy didn't get out onto the pad, there's actually a piece of Kapton tape on there. But usually what I do, especially on a, you can see how huge the holes are on this, because like I said, that's where the relay mounts. Those holes are rather gigantic. Instead of trying to, you know, cut a hole in that, what I usually do on stuff like this is I'll make the trace, install it, and then after the epoxy is cured and I pull the Kapton tape off, I'll just punch a hole through. It's a lot easier to do it that way, because once the epoxy is cured, the trace can no longer move. It's glued to the board now. It's, you know, basically a permanent part of it. So I just thought I'd show you how I do that. So, and what I'm using for basically a heat gun is a Hosan. It's actually a surface mount, a hot air surface mount reflow tool. I have a bunch of different tips for that, and this one's actually for a quad flat pack. It's a nice big tip, but it's perfect for heating, you know, large areas on circuit boards like this. So instead of it being only, you know, maybe a quarter of an inch away from something I'm actually trying to solder, I just set the temperature down on it, boost the air, you know, the airflow up, and keep it up off of the board, and works great for heating up circuit boards. Yeah, right where I like it, right around 180. So perfect. So next time you see this, it'll have a relay installed. Okay, so you can see the 1040 is all back together now, and I actually have it hooked up. Now, the customer asked if I could go over how to properly use this thing, because it does a lot. Well, actually not just it. You need 3 other things. You need a frequency counter, an oscilloscope, and then ideally you would have the matching BK Precision 2040 CB signal generator. But now I actually have that frequency counter and oscilloscope hooked up, which is what mine is normally hooked up to. Now, just so I don't have to string a cable the whole way over from the other side from the signal generator, I'm just using the communications test set here as an output. So it's outputting a 100 microvolts at 27.205 megahertz, channel 20. I have a CB hooked up right here. Matter of fact, I don't think I've ever even cracked the covers on that one to see. It's just one I got somewhere. But in any case, I just want to show it does work. So I have the speaker the speaker jack on the back of the radio is plugged into this cord, which goes into the receiver audio. And so we're now using the speaker inside of this. And you can see the audio power meter goes up and down. So, and you can even hear when it starts to get distorted, right around 3.5 watts. But this radio will put out 5 watts. So, other things popular with these, has the power meter, average and peak reading. So I have it on internal dummy load. We'll set it to average. And it also has 3 scales, has 10, 50, and 100 watts. You see we're doing just about 4 watts there. And then there's also the 100-watt scale. And if we go to peak reading, now this is where your audio generator built into this works for checking peak, because this has a 1 kilohertz tone or a 2-tone for doing sideband test. But you put it in 1 kilohertz, you just place the microphone over the cup, key the microphone, and yes, we can see it. Woo! Holy shit balls, Batman. Look over at the oscilloscope. Wow. Oh, wait a minute. Let me just connect that. There we go. That looks a little better. But yeah, we can see, wow, definitely boxcar. If I crank the volume up even more, right about there's what we want to see. 100% modulation. Yeah, that definitely, the modulation limiter is probably clipped in this radio. But let me plug the speaker back in on the radio here. But like I say, one of the nice things, you can also look at your audio waveform for received audio. So turn that off. So that's the actual audio being received by the radio, and we can also see that on the screen. Well, like I say, this is just a really quick to show that yes, she does work again, and it'll probably be a couple part series, the video I do on this, because like I say, it does so many things, and to go into any detail, it's just going to take a long time to go through all the different processes and measurements this thing will do and describe them, so people can have a good understanding of what a lot of those measurements actually mean. But there you go. There's a freshly repaired BK1040 CB Service Master.